Hey guys, today I'll be doing LeetCode Weekly Contest 182, and I'll be explaining my solutions afterwards. I'll just create a frequency erasing map. That's the answer, and then I loop through all values. Each soldier is soldiers can be part of multiple teams. Oh. I'll just loop through all triples. Okay, this looks good. This also looks good. For each person, I need station name and the time. And for each station name, I need the sum of the times. For each station, I have... Okay. I don't even think this is necessary, but whatever. P1 ID is equal to there. Oh, so actually this will be a pair of strings. Okay, so we'll put starting station is this, and this is the ending station, and then the time it takes is this. Then we return double add to p second divided by this. Well, what if there is not called it? It's always valid, okay. Pending, oh no. This seems like digit DP. Wait, this is actually a decently hard problem. No, 12, okay. Submit this. Accepted. Okay, so I'll do a DP. So the index I've matched, and then plus 7, okay. I also have 2 flags for if it's greater than or equal to S1. Okay, I'll subtract the first condition, I guess. Accepted. It's not okay, then we'll basically subtract. Starting from the back. Now I need to find the transition function. So we currently have a prefix of a size, and what suffix will we get if, what prefix will we get if we add some character? Okay. k is equal to I plus 1, because it can match that much. We check if the suffix of length k is a prefix. If substring starting from I plus minus k, then transition of ij is equal to k, and we break. Then it has to be equal to this. Yeah, okay. So now I have the transitions. Now I do the DP. So initial case is, wait, I messed up. I think this should work. Yeah, okay, so initial cases we have just then set the entire DP array. I just won't be lazy. I'll just then initially it's less than. Okay, so now we go from the back. Wait, what will the answer be? The answer will be EP0 and then this, and then needs to be less than. Okay. Loop through all possible characters that we can add. K less than 26. K plus 1 JL. Okay, so I need to calculate the new L first. New L is equal to, so if k is less than the character, then it has to be less. If k is greater, then it has to be greater. Otherwise, it's just the original one. Okay, and then you add it to DPI, transition from prefix of j, and then new L. And hopefully this works. Run code. And hopefully I did not overcomplicate this. Wait, what? Do I need to put this outside? Judging. Finish. It's actually correct first time. Whoa, okay. Didn't expect it to get accepted. Like, first time. I think the last problem was pretty hard, so I have a pretty good chance of getting first. this the final ranking or has it updated yet? Oh, I'm probably first. I think I'm first. I might even be first by a huge margin this time because of the harder question 4. But anyways, I'll go over the solutions. Okay, so for problem 1, lucky integer is an integer which has a frequency in the array equal to its value. So for each value, we should calculate its frequency in the array. And I do that with a map. So for each element in the array, I add 1 to the frequency. And after this loop, map will store the frequency of all the elements. And initially, the answer is -1. I loop through all elements in the map, and it gives the values in order. And p.first is the key of the map, and it's the value. And the second element in the pair is the frequency of the value. It's the value in the map. So if the key is equal to the value, then that means this value is lucky, so we set that to the answer. Yeah. Okay, so for the second problem, basically we just check, we can check each triple ijk, and since n is just 200, this is fast enough to pass. So we just loop through each triple using a triple for loop, and we check for the conditions. We check for the 2 conditions in this statement here, and if the condition is true, then we add 1 to the answer. Yeah. Okay, so for the third problem, so first we need a map to store for each customer the station he came from and at what time. So that's map 1 here. So the key is the ID of the customer, and the value is a pair representing the station that he got in and the time which he got in. So when he checks in, I add a new value. I add a new pair into the map. The key is just the ID, and then I add the station and the time. And then when he checks out, first I find the information from the map, which is stored in P here, and then I erase the customer from the map since he exited the underground system. So then, in order to calculate, and then for the third query, we need to store for each pair of starting stations and ending stations the total time that it takes for the customers and how many customers have traveled from the starting station to the ending station. So that's what I do over here. So in the second map, the key is the pair of starting and ending stations. And for the value, I also have a pair of integers. The first element represents the number of customers which traveled between this pair, and the second value represents the total time of all customers who have traveled between these 2 pairs. So in my checkout function here, so this pair Q is just the pair of starting station and ending stations, and then I add 1 to the total number of customers, and I add t minus p.second for the total time. T is the time which the customer gets out, and p.second is the time at which the customer gets in. So this is the time that the customer took. And for get average time, I just query the map for the starting station and the ending station, and then I just divide the total time by the number of customers. Yeah, this is pretty simple conceptually, but takes a bit of time to implement. And then for the last problem, this is actually This is actually a pretty standard problem, but it's much harder than the other LeetCode weekly contest problems. So the first observation is we want the number of strings that are alphabetically greater than or equal to S1 and alphabetically smaller than or equal to S2. So, and we can use a trick to make this simpler. So if you want a number in this range, we can actually change it into the number in this range subtracted by the number in this range. And we can do the same thing for strings as well. Basically, you'll calculate the number of strings which are smaller than or equal to S2, and then we'll ignore this condition first. Then in order to subtract this, we'll calculate the number of strings which are less than S1. Okay, so my solve function basically takes in a string and takes in n, a string, and the evil string, and it returns the number of strings which are less than or equal to S2, which are less than or equal to S. And then in order to subtract those which are not greater than or equal to S1, so what I do is first I check if S1 is just all A's, and if S1 only consists of A's, then any string will be greater than or equal to it, so I don't need to do anything. But otherwise, if S1 has some character which is not A, then what I'll do is I'll subtract 1 from S1. Similar to here, I subtract 1 from L here, and I subtract S1 from 1 from S1 here. And the way you do that is you consider the string as a base 26 integer. So you basically subtract it like you would for like other numbers. So if S1, we start from the right character, and if the current character is greater than A, then we just subtract the character and then we can break. But if the character is A, then that means we need to like carry, or I think it's borrow. Yeah. Anyways, we set it to Z and we subtract 1 from the character to the left, similar to how we do subtraction with base 10 integers. And then after we find the new S1, we basically call the solve function again for S1, but this time instead of adding, we subtract. And then we return the answer. So now we reduce the solve function to just one string, and it makes the problem simpler. And the problem becomes like we need to make sure the string we construct is less than or equal to S. And this is very similar to digit DP problems. So that's what we're going to do. This DP here means, okay, so DP ij k means it means we selected characters for this range, for the suffix starting at I, such that the maximum prefix such that the maximum prefix of this string from 1 to I, from I to N is, which is also a suffix of the string E, has size j. Okay, so what I mean by that is, so we constructed some string starting from index I all the way to n-1. And then how do we make sure that we don't contain the string evil. The way we do that is let's say evil is actually just evil. Then if we're given that none of the strings here contain the string evil, then we just want to make sure that we don't create the string evil in a prefix. So what you do is, if the string we construct starts with VIL, then that means then j will be equal to 3, because the maximum prefix of the string we constructed, which is also a suffix of the evil string, has size 3. And that way, we keep this information so that we know the next string cannot be E, because if the next string was E, then we'll complete the evil string. And then if the evil string is like, if we put IL for the first two strings, for the first two characters, then j would be 2, using a similar reasoning. And what you want to do is, when we add a new character in the DP, we loop through all possible 26 characters. And if, for example, if we add an A, then we need to know the new prefix, which is also a suffix of the evil string. And if we add an A in this case, then j will become 0. However, if we add an V, then j will become 3 instead. So in our DP, we need to know, given that the size of the prefix which corresponds with the evil string, has size j, what will happen if we add a certain character at the beginning of the string. Okay, so, and then the k over here, and k is 0 if the current string is greater than s, if the current string is greater than s, and k equals to 1 otherwise. Okay, so the answer is just when I is equal to 0, we build the entire string. So, and then we loop for j from 0 to all the way up to 1 minus the size of the evil string, because we don't actually want the entire evil string. And then k is equal to 1 because we want to make sure our constructed string is less than or equal to s. So that's the answer. And okay, so now I'll describe how we can find the transition. So how can we calculate the new value of j? And it's stored in the matrix tr here. So tr I of j means we have suffix of e of size I, and new size if we add character j. Okay, and by the way, instead of suffix, I calculated for prefix in this loop here, and I realized that mistake until only after I complete the entire loop. So by reversing the evil string, I change the prefix to suffix. Okay, so we loop through I, and then the current string is the substring from 1 to 0 to I, and of size I, and we loop through all possible new characters that we can add. So, and then string g is the new string. Then for each size starting from the biggest one, we check if the substring in g we check if the new string has a suffix of size k, which is equal to the prefix of size k of e. And if it is, then that's our new size and we set that to to the value in our transition matrix. Okay, so after we do this, it's just initializing the DP values, and then this is the base case for the DP. So if we haven't selected any characters so far, so the suffix is empty, and then if the suffix is empty, then the maximum prefix, which is also suffix of e, has size 0, and then by default we'll say that an empty string is smaller than or equal to an empty string. So k is equal to 1, and then yeah, we set it to 1. And when we loop through all characters starting from the right to left, and we loop through all possible j, and then we loop through all possible new characters we can add, and then we loop through all possible l. So this means that we want to find the new states that we transition to if we transition from this state. So in order to calculate the new value of l here, basically if the new character is smaller than the character in the string, then our string will be less than or equal to the given string. If the new character is greater than the character in the given string, then the string we're building will be greater than the given string. And otherwise, if the character is the same, then that means we need to compare these two strings by comparing their suffix. So the state of so what I mean by this is, we have two strings, they both have the same character here, then we compare them by comparing their suffix, and the comparison of their suffix is just stored in L. So yeah, so that's why we set the new value of L to the old value of L. And then, as I said earlier, the new state is just I, and then we transition, and then the new value of j is the size when we add character k to a prefix, to the suffix of e of size j. And yeah, we basically just transition by adding our old value to the new state. Yeah, and that's pretty much it for this. Yeah, so this was a really complicated problem. If you have questions, then be sure to ask them in the comment section below, or you can also go on my Discord server and ask the questions, because I'm starting to get a lot of comments and I sometimes miss some of them. And if you enjoyed this, then feel free to like and subscribe. Thanks for watching.